Hello students, welcome to my channel. Today I am here to teach you chemical reactions and equations, which is the first chapter of class 10 cbse science, and that is from your NCERT book. So let us begin. So my first part I have covered about how to write the chemical reaction and what a chemical reaction, why does this chemical reaction takes place. So in this class we will study about balancing the chemical equation, balanced chemical equations. So chemical equations, if the number of atoms on the reactant side and number of the atoms on the product side doesn't remain the same, it has to be balanced. So when that is an unbalanced equation, the number of atoms on the reactant side and number of atoms on the product side doesn't match, we need to balance those equations. So let us see how we have to do them. Balanced chemical equations. Recall the law of conservation of mass that you have studied in your class 9. Mass can neither be created nor destroyed in the chemical equation. That is, the total mass of element present in the products of a chemical reaction has to be equal to the total mass of elements present in the reactant. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. So we have studied about law of conservation of the mass. So you have studied this law of conservation of the mass in your previous class, that is in your 9th standard. So what this law tells about? This law tells that the atoms on the reactant side and the atoms on the product side remains the same in the sense, when a chemical reaction takes place, neither the atoms will be created nor the atoms will be destroyed. So a chemical reaction takes place, but the number of atoms present in the reaction will remain the same. So the total mass of the elements present before the reaction and the total mass of element present after the reaction, that is in the products, will be the same. That means the number of atoms in the reactants and the number of the atoms in the product must be the same. So that is why we will balance the skeletal chemical equation. So how we have to balance the skeletal chemical equation, we are going to learn in today's class. So in the previous class we saw that there was a chemical reaction we studied about, that is magnesium ribbon burnt in the presence of oxygen to form magnesium oxide. So this reaction was not balanced. Let us learn about balancing a chemical equation step by step. The word equation for the activity 1.3 may be represented as zinc plus sulfuric acid gives zinc sulfate plus hydrogen. So the above equation, the above word equation might be represented by the following chemical equation. Zn here stands for zinc and H2 stands for H2SO4, that is the sulfuric acid. When zinc reacts with the sulfuric acid, we get zinc sulfate and hydrogen gases evolved or released out as the product. So in the reactant side you will find zinc and sulfuric acid, Zn plus H2SO4. H2SO4 here stands for the sulfuric acid and Zn stands for the zinc metal. So when these reactants or the chemical reaction takes place between these two reactants, we will get zinc sulfate, ZnSO4 plus H2. So this will be the reaction. So do you think this is a balanced one? So let us see. Let us examine the number of atoms of different element on both the sides of the arrow. So let us first list down the elements. So we saw zinc, hydrogen, sulfur and also oxygen. So the number of atoms on the reactant side, that is on the LHS, the left hand side, and the product side, that is the RHS, the right hand side. So we saw Zn on the reactant side, 1 atom of Zn and 1 atom on the product side. So the atoms of the zinc are balanced. So let us come to the next atom, that is hydrogen, H2SO4. That is in the sulfuric acid we find 2 atoms of hydrogen, and again the hydrogen gas got evolved, that is H2. So 2 atoms of hydrogen. So hydrogen is also balanced here. The sulfur, so H2SO4, yes, 1 atom of, yes, that is sulfur, and ZnSO4, that is 1 atom of sulfur. So even the sulfur is balanced. So next let us come to oxygen. Oxygen, H2SO4, O4, that is 4 atoms of oxygen, and on the product side ZnSO4, that is 4 atoms of oxygen. So both the side the oxygen atoms are also balanced. So this is a balanced equation. You need not balance here. We saw that the number of atoms on the reactant side and the number of atoms on the product side both are the same. So we have 1 zinc atom, hydrogen atom, 2 hydrogen atoms each, sulfur, 1 each sulfur atom, and 4 oxygen atom on both the side. As the number of atoms of each element is the same on both sides of the arrow, equation 1.3, that is zinc reacting with the sulfuric acid, is a balanced chemical equation. So let us try this with the other chemical equation. Fe, that is iron reacting with water, that is Fe3O4 plus H2. So iron reacting with water to form ferric oxide plus hydrogen gases evolved. So let us see here, list out the elements, the number of atoms both on the reactant and the product side. So to balance a chemical equation, first draw boxes around each formulae. Do not change anything inside the boxes while writing the equation. So you have to make a box, that is for listing out the, do not change anything inside the boxes while writing. So first you write down the reaction and then go to the next step, that is make a tabular column in which first you write down the elements, number of atoms in the reactants and number of atoms in the product side. So elements, what we saw, that is Fe, hydrogen and oxygen. So in the reaction we saw Fe, one atom of Fe each, 1 atom of Fe in the reactants and 1 atom of Fe in the we got 3 atoms of Fe on the product side. So here 1 atom of Fe on the reactants and 3 atoms of iron on the product side. So that means here you have a imbalance of the atoms on both the sides. So hydrogen, both the sides, H2, yes, and the hydrogen atoms are balanced. So let us see with the oxygen atoms. So on the reactant side you have 1 oxygen atom, but whereas in the product side you have 4 atoms of oxygen. So we can see the atoms of iron and atoms of oxygen are imbalanced. So let us see what we have to do for balancing it. Let us come for the third step. It is often convenient to start balancing with the compound that contains the maximum number of atoms. It may be a reactant or the product. In that compound, select the element which has maximum number of atoms. Using this criteria, we select Fe3O4 and the element oxygen in it. So as we saw that oxygen here has more number of atoms, and we have to select the compound which has more number of atoms to be balanced. So we have oxygen 4, that is maximum number of atoms. So there are 4 oxygen atoms on the RHS side and 1 oxygen atom on the LHS side. To balance the oxygen atom, so we have to make a tabular column. Let us see here, atoms of oxygen in the reactants and in the product side. So initially we have 1 atom of oxygen in the reactant side and 4 atoms of oxygen in the product side. So let us balance it. To balance, you have to multiply that number. So 1 into 4. So if you do 1 into 4, that you have one atom of oxygen on the reactant side. So if you make that one atom into 4 atoms, or you multiply that with the number 4, as we have in the product side as a 4 atoms of oxygen. So by taking that 4, you multiply that with the 1 atom of oxygen, 1 into 4. To equalize the number of atoms, it must be remembered that we cannot alter the formulae of the compound. So we can't alter the number like Fe. So what we have studied, Fe3O4, we can't alter this compound. So only we can alter, that is on the reactant side we had oxygen, that is H2O. So we have only one atom of oxygen, so we can alter that, that is by making that 4H2O, that we cannot alter the formula of the compounds or the elements involved in the reaction. For example, to balance oxygen atom, we can put coefficient 4 as 4H2O and not as H2O4. So you can't change the formula by writing H2O4, but instead you can write the coefficient 4 in front of the water molecule, that is H2O. Now the partly balanced equation becomes Fe3 plus 4H2O, and that gives Fe3O4 plus H2. So step 4, Fe and H atoms are still not balanced. Now when you multiplied that with 4, the number of hydrogens also got increased, and we have not balanced the Fe. Pick any of these elements to proceed further. Let us balance hydrogen atoms in the partly balanced equation. So let us balance the hydrogen and then we'll go to the Fe. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS side. So what we did, multiplied the LHS with the coefficient 4. Now what we'll do, we'll balance that by multiplying that with the 4 on the RHS side. So that becomes, so in the reactants, so we will get 4H2O, that is H2, 2 multiplied by 4, that means we have 8 molecules in the reactant side, and in the product side we will multiply that with the coefficient 4. We have H2 gas released out, right? That will multiply with the coefficient 4, that is 4 into 2, that becomes 8 molecules. 8 molecules of hydrogen on the product side and 8 molecules of the hydrogen on the reactant side. Now the hydrogen atoms are balanced. So when we got this balance thing, we will write the skeletal equation, Fe plus 4H2O giving Fe3O4 plus 4H2. Now the oxygen atoms and the hydrogen atoms are balanced. Now we will balance the Fe. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. So initially we will find one atom of iron in the reactant side, and the product side we find 3 atoms. So one atom, as we did in oxygen, we multiplied that with the number of atom, maximum number of atom present on the product side, that is 3 molecules of iron will be multiplied with 1 molecule of iron present on the reactant side. So to equalize the Fe, we take 3 atoms of Fe on the LHS side. So we will write the chemical equation, 3Fe plus 4H2O, Fe3O4 plus 4H2. Now the equation will be balanced. So as the number of atoms on both the sides are balanced, so 3 atoms of iron and 3 atoms of iron in the product, 8 atoms of hydrogen on the reactant side and 8 atoms of the hydrogen on the product side, 4 atoms of the oxygen on the reactant side and 4 atoms of the hydrogen oxygen on the product side. So now the equation is balanced. Step 6. Finally, to check the correctness of the balanced equation, we count the atoms of the each element on both the sides of equation. The number of atoms of elements on both the sides of equations are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method, as we make trials to balance the equation by using smallest whole number coefficient. So this method which we use for balancing the chemical equation, that is called as the hit and trial method, has been checked with the number of coefficients by balancing the number of atoms present on products and the reactant side. So write step 7. So writing symbols of physical states, carefully examine. The above equation is balanced now. Does this equation tell us anything about the physical state of each reactant and the product? So we should also mention some physical state in which the reaction is taking place. No information has been given in this equation about their physical state. To make a chemical equation more informative, the physical states of the reactants and the products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous and solid states of reactants and the products are represented by notations G, I, A, Q and S. S is for solid, G is for gaseous, L is for liquid and AQ is for the aqueous respectively. The word aqueous is written if the reactant or the product is present as a solution in water. So why do we write this as aqueous, even that aqueous is in the form of liquid? So aqueous is nothing but it is a solution, it is a mixture of water and any other compound. So now if a chemical equation is given, to make that more informative, we can write the physical state, that is either that is in the form of, or the reactant or the product is in the form of gaseous state, liquid state, solid state or aqueous state. So we will write G for the gaseous, L for the liquid, S for the solid and AQ for the aqueous. Aqueous is nothing but it is a solution of water and any other compound. So note that the symbol G is used with H2O to indicate that in this reaction water is used in the form of steam. If H2O is written in the form of G, so we can see here 3Fe, that is in the bracket given, yes, that is iron is in the form of solid when that reacts with the water which is in the form of gas. So water, how can this water molecule be in the form of gas? That is in the form of steam. So that gives Fe3O4 which is also in the form of solid and 4H2 that is in the form of gas. So when you write G in front of a water molecule, that means it is in the form of steam. Usually physical states are not included in the chemical equation unless it is necessary to specify them. So usually we don't write any physical state till it is necessary to do so. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reactions are indicated above and below the arrow mark in the equation. For example, so you can see a carbon monoxide reacting with hydrogen at 340 atmospheric pressure. So that will form CH3OH which is in the form of liquid. So it is sometimes the conditions of the reaction should be written, that is the temperature, the pressure and the addition of the catalysts. So it is written here, that is 340 atmospheric pressure on the top of the arrow mark or the below the arrow mark. So the second one, that is the reaction chemical equation of the photosynthesis, where the sunlight and also the chlorophyll is written. That means photosynthesis takes place only in the presence of this sunlight and the chlorophyll. Using this step, can you balance equations given in the text earlier? So if you have come across many chemical equations, try to balance them. So in my next class, so thank you, in my next class I'll be teaching you or solving some of the questions which is given in your NCERT text. So how we have learned to balance the chemical equation. The main thing is you have to keep in the mind about the law of mass of conservation. That means the atoms in the reactant side and in the product side should always be the same, because the mass of the elements in the reactant can neither be created nor destroyed. That means it will remain the same after the chemical reaction takes place. So first you have to count the atoms on both the side and go with the hit and trial method, that is multiplying with the maximum number of atoms present on the other side. So if you do this, you can easily balance your chemical equation. Please try this with other equations possible, and in my next class I'll be solving the questions or the exercise which is given in your NCERT text. Thank you.